In this video we are going to explore further questions containing indices. First we're going to look at expanding brackets. So for the first one I'm going to be doing x squared multiplied by 2x. Well, that is just going to be 2x cubed. If you don't know where that's come from, we can break it down. X to the power of 1, we could rewrite that as the coefficient of x is 2, the coefficient of x squared is 1, so I'm going to be doing 1 multiplied by 2, which is 2, and then using the multiplication law for indices, I can have 2 add 1, so I'm going to have x to the power of 3. That's where that's come from. I'm going to be using the multiplication law for the next part, so x squared multiplied by x to the power of minus 1. Well, I'm going to have an add x, and then let's work out the power. Well, we are adding the powers, so 2 add minus 1, that's the same as 2 minus 1. So it's going to be x to the power of 1. Now, I'm not going to leave it as that, I'm going to just keep it as x. Let's go on to this one, expanding double brackets. I'm going to use the arches method. You can just use whichever method you're most comfortable with. So x squared multiplied by x cubed is going to be x to the power of 2 add 3, which is 5. X squared multiplied by 3 is going to be 3x squared. 2 multiplied by x cubed is 2x cubed. And then 2 multiplied by 3 is plus 6. Just checking, there's nothing I can combine together. The only thing is I could probably move this x cubed in front of the x squared, because you tend to write expressions in decreasing powers of x. But for the purpose of this example and any future examples, it's going to mean the same thing. So I'm going to leave it as it is. Let's have a look at this one. 2x squared multiplied by x to the power of 5 is going to be 2x to the 2 add 5, which is x to the power of 7. And then 2x squared add 2. So multiply those two together, we're going to have 4x squared. Then we've got minus 3 multiplied by x to the power of 5, so minus 3x to the power of 5. And then minus 3 multiplied by 2, so we've got minus 6. Again, there's nothing I can collect, and I'm going to leave it as this. Let's move on to the final one then. X to the power of a half and x to the power of a half. So multiplying them together, I'm going to have x to the power of, well, a half and a half, or 0.5 and 0.5, is 1. Then I'm going to do x to the power of a half multiplied by 5, which is 5x to the power of a half. And 2 multiplied by x to the power of a half is 2x to the power of a half. And then we've got 10, because 2 multiplied by 5 is 10. Now I can do some simplifying here. I'm going to rewrite this as x, and then I'm going to combine these two to get 7x to the power of a half, and I'm going to add 10 on the end. I'm going to look at solving equations now, which involve indices. So for the first one, 2 to the power of x is equal to 64. I need to work out what x is. Now, 2 to the power of something is 64. Well, 2 to the power of 6 is 64. So I know that x is equal to 6. Just a note, there's capital X's and the usual curly X's here. I'm just going to keep everything and pretend everything is a curly X. This one, 3 to the power of x is 81. Again, I'm thinking about what that x needs to be. I know that 3 to the power of 4 is 81, so x is equal to 4. These ones you can spot. Now let's move to the next one. 2 multiplied by 3 to the power of x is equal to 54. Now, I'm going to move this 2. We've got a multiply here, so I'm going to divide both sides by 2. So I'm going to be left with 3 to the power of x is equal to 27. And that's much nicer to work with. Now I know that 3 cubed is 27, so x is equal to 3. Let's move over here. Now, slightly different style to work with. I need to get the base the same for both of these terms. Because if the base is the same and they're both equal to each other, then I can just compare the powers. So how will I get this 8 to the power of x to be the same as 2? Like the base to be 2? Well, I know that 2 cubed is 8. So I'm going to rewrite 8 as 2 cubed. And then still have it to the power of x. And that's going to be equal to 2x plus 4. Now I'm going to actually just use the brackets law here. So 2 to the power of 3x is equal to 2x plus 4. Now the bases are the same. I'm just going to forget about those for a minute and compare the powers. So I have 3x is equal to x plus 4. Now I've just got a simple solve. And I'm going to move this x over to the other side. So minus x from both sides. I'm going to be left with 2x is equal to 4. And then from there I can divide both sides by 2. And I'll have x is equal to 2. If you're unsure of any of these, you can actually check. So if I wanted to check my answer here, I could substitute 2 into this equation above. So 8 squared is 64, and that should be the same as 2 to the power of 2 add 6. Well, 2 to the power of 6 I know is also 64. So both sides equal the same thing. Now I've got 3 to the power of 2x add 1 is equal to 27 to the power of x minus 2. I need to get the bases the same again. This is 3 here, so that's quite a good base to work with. So I'm going to try and change the 27 to have a base of 3. So let's start by writing that out. And then I could write 27 as 3 cubed. And then I'm still going to write the power of x minus 2. Now I'm just going to expand out the right hand side. And what I mean by expand out is using the brackets law for the powers here. So I'm actually going to have 3 to the power of, now be careful, I'm almost doing 3 multiplied by x minus 2. That's why I mentioned an expand, because I'm going to be doing 3 multiplied by x and 3 multiplied by minus 2. So I'm going to have 3 to the power of 3x minus 6. Now I've got the same base, so I can just compare the powers. 2x plus 1 is equal to 3x minus 6. I'm going to start by moving this 2x over to the other side. So minus 2x from both sides. I'm going to have 1 is equal to x minus 6. And then I'll move the minus 6 over. So add 6 to both sides. And I'm going to be left with x is equal to 7. Let's have a look at this one. We've got the quarter to the power of x plus 2 and 32 to the power of x. Again, I need to find the same base. Now this isn't as straightforward as the other ones because it looks like I'm going to have to manipulate both sides. Now a good base to try and start with is 2. So I'm going to change this a quarter to be, to have a base of 2. So I'm going to break this down a little bit. Let me think about it. 1 over 2 squared, I could rewrite that as, and still to the power of x plus 2. And then this one, well, how am I going to get a base of 2? Well, I know that 2 to the power of 5 is 32, and it's all still to the power of x. So now let's try and get rid of this fraction part. I'm going to use my knowledge of negative powers. So I'm going to rewrite that as 2 to the minus 2 to the power of x plus 2 and equal that to 2 to the power of, now I'm actually going to expand this out, 5x. Now I'm going to have to expand this part out. So I'll have 2 to the power of minus 2x minus 4. And just to make space, I'm just going to rewrite that there. So 2 to the power of minus 2x minus 4. Now I can compare the powers. So I've got minus 2x minus 4 is equal to 5x. So I'm going to move this 2x over. So add 2x to both sides. I'm going to be left with minus 4 is equal to 7x. And then dividing both sides by 7, I'm going to have x is equal to minus 4 over 7. Let's have a look at the last two. 8 to the power of x plus 1 is equal to 1/16. Again, I've got to get the same bases. A good base to start off with is 2. So I know that 8 can be rewritten as 2 cubed. And then it's still to the power of x plus 1. And 1/16 could probably be rewritten as 1 over, now 2 to the power of 4 is 16. Let's use the brackets law and expand this out. So 2 to the power of 3 x plus 3 is equal to, now here let's get rid of the fraction and use the negative power law. So 2 to the power of minus 4. Let's compare the powers now. 3x plus 3 is equal to minus 4. And I'm going to move this 3 over, so take 3 from both sides. 3x is equal to minus 7. And then I'm going to divide by 3 on both sides. So x is equal to minus 7 over 3. And again, if you are unsure at all, you can check these. And you can check these by plugging them in and even using your calculator. Because when you plug in the value of x into here, it's going to be numerical powers that you're working with. So you don't have to calculate them mentally. You could input them into a calculator and check that the left-hand side equals the right-hand side. Let's go to the last one. We've got 2 to the power of x squared plus 2, and that's equal to 8x. Now I'm going to start at the right-hand side and change this 8 to have a base of 2. So 2 to the power of x squared plus 2 is equal to 2/3 to the power of x. Sorry, not 2/3, 2 cubed. Now I've got 2x squared add 2 is equal to, let's use the brackets law, 2 to the power of 3x. And now I can compare the powers. So x squared add 2 is equal to 3x. I'm going to move the 3x over by minusing 3x from both sides. And I'll be left with a quadratic that I need to solve. So relying on previous knowledge, it would probably be best to look at factorising this and then solving from there. So I'm going to factorise this quadratic into 2 brackets, and it's still going to be equal to 0. So remember, we are looking for two numbers that multiply to give 2, and the same two numbers that make minus 3x when multiplied out. So 2 is prime, so as well as putting x and x in here, I can also put 2 and 1 in here, because 2 and 1 are the only factors of 2. Now I've just got to think about the signs. I need a positive 2, but I actually need a negative 3x. And the only way I'm going to get that is by having two negatives. Now, x minus 2 is either equal to 0, x minus 1 is either equal to 0, or they're both equal to 0. So, x must be equal to 2 for this bracket to be equal to 0, and x must be equal to 1 for this bracket to be equal to 0. So in this example here, we've actually got two solutions for x. So that means when I plug in x is equal to 2, it works. And when I plug in x is equal to 1, it also works. So it works if the left-hand side equals the right-hand side. Feel free to pause this video and check that it works. Now I've covered some examples on solving equations. I want you to have a go at these questions. These feature in the notes. So this will be the end of the video once you've had a go at these questions.